the emerging technologies are being used by the organizations to address the water challenges in the country. Taking it forward, I would now like to introduce the moderator of this section, Dr. Pavan. Dr. Pavan is the Chief Scientist and Head, Water Technology and Management Division at National Environment Engineering Research Institute. He is working in the field of water resources management with specialization in water quality monitoring, water treatment, water safety plan, grey water treatment and reuse, and much more. I would now request Dr. Pavan to please take the session forward. Over to you, sir.
Yeah, thanks, Divya, for introduction, and good afternoon, everyone. I welcome audience and more importantly, our speakers today. So today's topic is very, very interesting. In fact, we'll be talking about application of emerging technologies to address water challenges. And as Divya told, this is really important, and I'm really fortunate to have speakers from different facets, working in government, research institute, and private companies, and they really would make good mix of speakers. So coming back to today's topic, we'll be definitely discussing about application of artificial intelligence in solving today's problem. But while I'm working in NERI since 1989, January 89, I completed 33 years and worked a lot in say water domain. So I feel that apart from artificial intelligence, we also require technological development in many say areas. So when we talk about water supply systems specifically, I feel that we need technological intervention right from catchment to consumer. And if I take some example, how can we actually take these technology forward, say from catchment? So you might have read today's Times of India, and they're talking about say precision agriculture. You know that more than 75% of India's water go for agriculture, irrigation. And if we apply this artificial intelligence and machine learning, I'm sure that with advent of so many sensors, we can bring down water demand for agriculture. We also did a small study here in Nagpur. Rather, we are continuing the study, and you know, I've come from Nagpur, and we have like orange orchards around Nagpur. And when we did study that how much an orange plant require water for irrigation, we were surprised to know that it requires only 8 to 10 liter of water every day for irrigation purposes. And National Horticulture Board's standard is almost 60 liter per day per plant, whereas the farmers here use almost 400 liter per plant. So you know that how much water we are actually wasting. And if we can use different technology as we use to determine that will really help us to come out with better technology. And today's Times of India, in fact, talk more about this particular requirement of water for irrigation. I'll come to say surface water reservoir, from where most of the cities in India get water for drinking water supply. And I had recently been to Latur and found out that there are 4 intake wells at the dam. Unfortunately, 3 were not working. Only 1 was working. If we can come out with certain findings, how to operate these walls at intake, so that we can draw water from a point where there's a less pollution. You might be aware that we have like thermal stratification in reservoir. And we normally draw water. We should normally draw water from upper surfaces when the reservoir is full. We can go to the down when it's not full. But at the same time, we should try to say model water quality at different levels of reservoir, so that we can draw water at the level when which is less contaminated. Okay, coming to the next step in entire water supply system, that is water treatment plant. A lot of work in water treatment plant. You know that we still use conventional water treatment plant, and the latest technology in conventional water treatment plants is rapid filter, which was developed way back in 1904. It's more than 100-year-old technology. We still rely on that. We created assets. Now we design these plants based on a certain source water quality. Unfortunately, due to wastewater discharges and non-point sources, the source of these water supply systems are getting affected. You get many, say, emerging contaminants. At the same time, we have received, I think, complaints from at least 10 municipal corporations. How this proliferation of algae, cyanobacteria in the water, and our treatment plants are not meant to treat water having algae or cyanobacteria. So we need technology to, say, retrofit our treatment plant. More importantly, in cost-effective manner, so that all municipal corporations which have very little money to operate and maintain these plants can rely on these technology. How can we actually model source water quality? That's, I think, the where artificial intelligence can really add to this particular aspect. I think the distribution system, which is the backbone of entire water supply system, and Dr. Baban will definitely be talking about it. You might be knowing that we have intermittent water supply system, and you might even be aware that we add chlorine. We have like a substantial quantity of chlorine. Unfortunately, in intermittent water supply, we consume a lot of chlorine. See, if we design our system based on continuous water supply, then the chlorine consumption will be much lower. And whatever residual chlorine we are talking about at tail end, those residual chlorine will not be available. So we need something, sensor development, so that we can predict how much will be chlorine. We need optimization of this distribution network model, so that we can predict how much will be chlorine at tail end. And I think we shouldn't talk much about NRW. We are really concerned about, say, NRW. We have in India, we talk about like 40%. Our benchmark is 25% of NRW in India, but we still lose a lot of water. So can we, with the help of not only artificial intelligence, but even other technologies also can treat. You might have also heard about deterioration in water quality in our existing system. So how can we prevent that? Can we use a system like pigging, which is used in Western country to clean up biofilm which gets formed in the distribution system? There's a lot to be done as far as the technology is concerned. Coming back to the last point in household, yeah, our responsibility as municipal corporation, our public health engineering department, and set down those step up in household. Whereas if you see, we did a study in Nagpur, we found out the water quality at household, at say at drinking water level is as bad as that at source. So whatever investment we are doing in treating water, it goes waste. So to see that how best we can say keep the water quality intact, not only in entire water distribution system, but even at household also. And if you talk about, say, membrane processes, we have reached to, I think, plateau. We have reached to thermodynamic level where we can't go further in terms of, say, efficiency of treatment for RO, even salt rejection for that matter, even reject. So we need to really work on these. How can we further improve? Because we cannot plan for some of the eventualities which are emerging, not only because of, say, disposal of sewage into water, but even due to climate change also. So I'm sure that all these issues will be discussed by our speakers. So without much ado, now we'll go to our speakers, and we have like four eminent speakers with us today. We have Mr. Y.K. Singh, who is Director with Department of Drinking Water and Sanitation, Government of India. We have Mr. Uttam Banerjee, co-founder and CEO of Economico Solutions. I have my colleague Dr. Bhavan Bansood from CSRO Chandigarh, and Mr. Avinash Patra from Xylem, India. So my request to all the speakers is that if you can finish presentation in 15 minutes, that will be great. I'll be giving some small note to you at the end of 12 minutes. So we don't want to come between lunch and the presentation. So Over to you, Mr. Singh, first. So before I hand it over to Mr. Singh, I'll introduce Mr. Singh briefly. Mr. Y.K. Singh is a director with Department of Drinking Water Incineration, Ministry of Jal Shakti. Mr. Singh is an Indian Ordnance Factory Service officer of 2006 batch. He has done his BTech from IIT Roorkee, and after completing his BTech, he has done his MTech from IIT Delhi. He has also completed 1 year post-diploma in industrial safety from RLI Kanpur. And he's presently holding the charge of director dealing with new and emerging technologies in Department of Drinking Water and Sanitation. So with these few words, I now hand it over to uh, Mr. Singh for presentation.
Yeah, thank you, Dr. Pawan. You have given a broad outline of what are the challenges before us. And first of all, since I am here at the Jal Jeevan Mission, I will slightly give the detail of the Jal Jeevan Mission, how it is being implemented, what are the challenges being faced, how from the department we are taking help from the different offices, including a PSA office, and then support by Dr. Pawan and different IITs. They are contributing towards the solving the challenges which is being faced. So I will start my speak first from the briefing about the Jal Jeevan Mission. Jal Jeevan Mission is being implemented in partnership with the states and union territories. It was announced on 15 August 2019 by the Honorable Prime Minister of India with the target year of 2024 with the objective to provide Har Ghar Jal uh, as per the BS 10,500 quality norms. So the primary, since the water supply and sanitation are part of the state subjects, so we are giving them funding supports. We are giving them some technological choices which they are lacking, but the ultimate design and implementation lies with the states. So, and we are basically addressing this water supply issues mainly in rural areas. Our focus is rural areas. So, whenever there will be a technology provider, he has to keep in mind that the focus of Jal Jeevan Mission is rural area, because that gives you challenges according to the area, the people who are residing there, and according to the availability of resources in the rural areas. So the program, how it happens is basically there is a central department in the state, generally PhD department, who in consultation with the Gram Panchayat initiates the single village scheme or multi-village scheme depending on the availability of water sources. And what they do is basically after implementing the scheme, they hand over it to the Gram Panchayat. This is very important, and it should be noted down that the schemes are handed over to the Gram Panchayat for operation and maintenance. So whatever technology is employed or deployed in the single village scheme, or to the network which is there available, in a distribution network which is available in the village, has to be maintained from the resources which is generated by the villagers through the Gram Panchayat, and the technical resources whatever are available at the disposal of Gram Panchayat, only that can be deployed for the operation and maintenance of the resources. So our technology innovator has to have this in mind, because if you are addressing a water problem in the city area, the focus will be different. But once you are addressing the technology problem in the rural area, since the population is different, their technical capabilities are different, resources are different, mindsets are different for paying for the money in the rural areas because of our historical legacy and all. So this has to be a prime focus in the development of technology. Similarly, there are lot many technology options are there uh, already existing, whether it is arsenic problem is there, whether it is fluoride problem is there, or other metals which we need to remove from the water to supply qualitative water as per the BIS standards. So there is a dilemma before the state agencies in choosing the technologies, although they have some inputs about, as Dr. Pawan was also mentioning, the technologies are generally designed for a specific set of raw water qualities. So the state agencies know the broad raw water qualities, but they do not know whether after the deployment of this technology, whether this technology is going to address the problem, which is the prime focus of the technology. In addressing that concern, the technology should not generate or create problems in the other parameters, which has also to be addressed by the BIS standards. So this challenge has to be there in the minds of technology providers. Then third thing is, when we deploy any technology, it is always either on the basis of some filter media or some chemicals we use. So we are basically generating some sort of either sludge or some sort of a reject water, or you can say some sort of uh, water which is not pure for drinking purpose, but it is a lot of contaminations. So the technology providers also has to address that, since we are going to address the rural population, they do not have the technical know-how, they do not have the sufficient funds for operation and maintenance. So the technology solution has to be friendly to the rural population. It should, the technology itself should give know-how of how the sludge has to be managed, how it has to be addressed, and it should not create the problems of the common villagers. To address the technology problem at the department level, we have been interacting with the Office of the Principal Scientific Advisor, and there is a very high level committee in which Dr. Pawan is also a member of that committee. He has been associated with that committee since long, and we have designed a portal on the website of DDWS, on which any innovator of the technology can apply for the innovative technologies or R&D projects they want to take, and that is evaluated on the basis of some set parameters in terms of what is the new thing you are going to do in that particular innovative technology. That has to be taken in mind, and how it is different from the available choices in the market, how it is going to give you the cost benefit analysis, cost benefit above the existing solutions which are there in the market, how it is going to give comfort to the rural population in terms of choice of the technology, how it is going to give the comfort to the rural population in terms of least technical involvement for operations and maintenance. So on the basis of these broad parameters, then its affordability, employability, economics and all, the high level committee is the technology, and since it is a state level subject, from center we do the recommendation of the technology depending on their problems faced by states they selected. During the implementation, it has been found that a village neighbor network is created. So now the problem as leakage detection is coming. There is a assurance of 55 liters per capita per day supply we have to meet as per the JJM guidelines. So there is a need for IoT devices. There is a need for uh, integrating it with our dashboard so that we can know, sitting in the offices, which single village scheme or multi-village scheme is delivering, what is the quality standards, what are the sufficiency and regularity of the water needs, which has been mandated by Jal Jeevan Mission. In that, lot of technological interventions are being done, and Dr. Babban Kumar and team is already executing the IoT based support systems. They are creating the environment, they are creating they are creating the many solutions in partnership with the states that will basically benefit a lot in monitoring the things and in ensuring that the qualitative water in the desired quantity is reaching to the rural citizens of India. If you see the efforts done by the department, that we have already done a technological context in which more than 100 IoT-based pilot projects are already there on DDWS website, which are being regularly monitored. They are reflecting the water quality parameters. Then they are reflecting the this quantity delivered per capita per day. And further, what I mentioned is CSIR and Dr. Baban Kumar and team is working further on the development of IoT devices, the whole network and ecosystems, and that is really a good job they are doing. So this is all the crux of the Jal Jeevan mission which I have put forward before here, so that you know what are the challenges in rural water supply, what are the needs of the technology providers which they keep in mind while addressing the concerns of the rural citizens related with drinking water supply and the department. So under these broad guidelines, we as a ministry uh, are open to the technology providers to come forward on our platform to show their technological innovations and help us in addressing the needs of the common man and achieving the goal of Honorable Prime Minister of India by 2024. Thank you. Over to you, Dr. Paul.
Yeah, thanks a lot, Mr. Singh. You touched upon a very important issue of consumer of technology, and you talked about in the context of JJM rural population, a Gram Panchayat is consumer, and the technology should be developed accordingly. So we have like couple of minutes, Mr. Singh. So I'll ask a small question to you. And you talked about this IoT enabled water supply system. And you talked that more than 100 projects are implemented, and Dr. Bhagaman and his team also is working on it. So yeah, can you give just small feedback on these IoT enabled projects which has been implemented? How's our experience on it?
Yeah, the IoT based pilot projects which have been implemented, that has been basically the outcome of a technology challenge which was conducted by MIT in collaboration with Department of Drinking Water and Sanitation. And in that, 100 projects were financed and it has been onboarded on the DWS website. They are reflecting, they are basically measuring the flow rate, pressure, how much water is daily being delivered to the point of use. So you are able to monitor as per JJM guideline 55 liters per capita per day is required. So you from that, while sitting in our office in Delhi, we know it is being done or not. Second thing, there are many quality parameters which are being monitored by that. So that are also reflected, and you come to know okay, what are the quality issues coming. And the second thing, which the second part, which is mostly handled by Dr. Baban Kumar and his team, that R&D project that has been being financed by Department of Drinking Water and Sanitation. They have already chosen many specific areas in the states of Tamil Nadu, Rajasthan, and many more states. And they are basically deploying the IoT based systems for monitoring 13, I think, Dr. Babban, 13 quality parameters are monitored. 13 quality parameters are being monitored in that.
Yes, almost close to that.
Yeah, and along with that, the pressure, flow rate, and quantity being supplied, regularity, and the best part of the project which is being done by Dr. Baban Kumar is we know that many of the sensors or parts are imported from outside in India for quality monitoring. So Dr. Baban Kumar and team has been given project. The second step of the project is indigenous development of the sensors. So that is very crucial because we are lacking in many sensors, indigenous availability, and a lot of sensors are being imported or either their components or in totality full sensors. So that will basically make us self-sufficient and self-reliant in terms of sensor availability in India and quality monitoring. So this is all about the work which is going on in IoT and the available systems based on the IoT.
Yeah, thanks a lot. It is very, very important, Mr. Singh. You talked about the details of this IAT-enabled water supply system, and Dr. Baban will be talking more about it in his talk or presentation. So I think thanks again for completing your talk within stipulated time. So with this, now we'll move to next presentation, and it will be by Mr. Uttam Banerjee, who's a co-founder and CEO of Ecom Eco Solution. So Mr. Banerjee studied product design at IIT Delhi, and he has also won several awards for his designs. It's really great to know Mr. Banerjee. He has more than 14 years of corporate and startup experience, and he oversees product development, management, and marketing. So with this brief introduction, I now hand it over to Mr. Banerjee to proceed with his presentation or talk.
Thank you, Dr. Pawan.
Thank you, Dr. Pawan, for the kind introduction, and thank you for giving me this opportunity to present the work that we have been doing. Can I just share the screen? I hope the screen is visible.
Yes, yes.
Okay, okay.
Yeah.
So we have started our work somewhere in 2013, officially in 2013, but the work around sanitation and sustainability has been carried out since 2009, and it all started as a college project. So when we started this off, the idea was to look at water or sustainability from a larger perspective, and we divided it into three different verticals or three different areas. So when we talk about water management or abundance of water, what we really feel is that there are three different areas where we need to target, and one of the first and foremost target area is to reduce the consumption wherever we can. That is one of the objective of our organization. And the second objective is to kind of not pollute what we have. So we have a lot of water resource, but we try to sort of keep that pollution free. And I'll explain how we are doing it through the technologies that we have. And the third stage is about whatever we are doing inside our home or inside our industries or cities and so on, we try to kind of treat it in a more sustainable and more economical way, more scalable way. So these are the three different objectives where we with which we actually started off this work. And yeah, and the idea is that if you look at the name of the company, it's called Ekam, which is a Sanskrit word. So the idea is to look at all of these things as an interconnected world, whether we talk about food, hygiene, health, agriculture, water, sanitation, everything is connected. And currently, most of these systems are actually open-ended. So the idea is to close the loop. We'll consume a lot of things and then we discharge a lot of things, but the whole system becomes kind of a linear system. It's not a cyclic system in most part of the areas. So the idea is, can we create a circular system? Can we create a circular economy around this whole subject? And through the application of designs and technologies and so on. So we have 6 different verticals. One, first and foremost, which is about managing the water that we consume inside the restroom, is what we do through the waterless technologies, waterless urinals and waterless toilets. We have composting and waste management solutions, which kind of treats the waste, different kinds of organic waste, whether it is coming from the toilet or it is coming from the overall house or even a commercial complex. And we treat it in a very different way. As Dr. Singh and Dr. Pawan was also mentioning, that the idea should be to look at these technologies so that you kind of minimize the output that is coming, which is primarily difficult to handle. Whether it is we talk about sludge, we talk about different kinds of components that comes out of the treatment systems. So that's the primary objective, that how do you treat it more efficiently and kind of create something useful out of it. So normally we call them waste, but at Ekam we like to call them as a resource. Nothing is a waste. The third and another significant vertical that we work on is the natural alternatives to these chemical cleaners, the housekeeping solutions that we have. And we kind of we thought that when we were actually experimenting with the toilet waste, we realized that there is a lot of chemical contamination that is happening in the toilet, because we are using a lot of hand wash or toilet cleaners or floor cleaners, And that is creating even more, it's even more challenging with these chemicals being mixed with the waste to treat. So we thought, before we go into that area of treatment, we need to also focus on alternatives that can go along with these toilet waste. That is not, that does not just make the treatment process easier, but also helps the treatment process. So I'll tell you how we are actually doing it. But before going into the treatment process and the cleaners, I'd like to briefly explain the technology that is kind of a bread and butter for us, I would say. And that's called as zero door waterless urinal technology. So the idea was that when we started looking at this sanitation space, we realized that there is a lot of flushing that is happening, inside the toilets, inside the urinals. And toilet, एक point के लिए you can say that, okay, there is a lot of solid sludge which needs to be moved from the space of the washroom to the treatment system. But urine is a liquid, so you don't need another liquid like water to push urine. So, and when we went deep into it, we realized that the only reason why we are flushing is because there is odor which is coming out from the urinal pans. And the odor is nothing but ammonia. So when we looked at it from a different perspective, we tried, understanding what all different products are available, and we found out that there are certain solutions available that they use chemicals to kind of suppress or mask the odor. And we didn't want to use that. So we developed our own mechanism, which was primarily a mechanical device. It's a purely mechanical system, a small handheld, attachment that goes in the existing urinal. So you don't need to change any infrastructure in the restroom. It goes along with the existing system. It's a retrofit item, and there is no chemical or there is no consumable. So it's like a one-time fitment for you. And it lasts like for 20-25 years. So we have installations which are in operation, successfully working for last 14-15 years. And this is a very kind of a frugally developed technology. I'll just first explain how it sorry. Yeah, so this is how the existing system looks inside the restroom. And it has a small floating valve inside this mechanism. If you look at this small part, there is a floating valve. The principle behind this mechanism is that the urine should flow into the waste pipe, but the gases which are generating in the drain line should not come out in the washroom, right? So we designed a non-return one-way valve using a float system, and we kept the specific gravity of the float system in between urine and ammonia. So when urine flows, when we urinate on the device, the system floats up, it opens up the passage, the urine goes out, and then it goes back and covers the whole in the pipeline, and the gases in the drain line are trapped and are not allowed to come back. So that's how it creates a one-way passage for the urine and the gas. And it's a very frugal technology. These are the other two technologies that are available in the market, which are based on some chemicals or membrane. The benefit with zero door is that it's a mechanical system, does not have any consumable, does not have any recurring cost. No power is required, and it's completely, kind of free of cost for you in terms of operational and all. So that's about the waterless urinal. Coming to the cleaning solutions, these are also, developed keeping in mind that there is a lot of contamination which is happening, and whatever we have, the natural resource, available resource we have, are getting polluted because of certain things that we use in our day-to-day lives. And we thought of, kind of mimicking the nature, how nature actually processes the waste. There are lots of different kinds of bacteria, good bacteria. There are lots of enzymes that we have in the nature, which can be, kind of cultivated and bottled and, packaged in the form of a product to kind of, whether it's about removing a stain or removing odor or in fact cleaning different surfaces. So you can do all sort of things. And we came with a range of solutions, whether you talk about drain cleaners, whether you talk about laundry wash or toilet cleaners, floor cleaners, hand wash. So all different kinds of solutions, a complete range of solution which has been created using different kinds of curated, specially curated enzymes. And many of us know how these enzymes work. So these are like, these solutions have bacteria in the dormant stage, and when we expose them to the dirt or stain, they become active, and then they start kind of, it's the stain or the dirt acts like a food for these bacteria, and they become active, they release enzymes, and these enzymes actually break these organic waste or dirt or stain into the basic components, which is carbon, hydrogen, and oxygen, and then it does the job. So it's almost very close to the kind of action that happens inside our gut when we consume probiotics or curd. So it kind of helps us digest the food even more rapidly and in a much efficient way. And the other benefit with these kind of products is that when these go in the drain lines, normally we flush them, right? Normally we wash them and it goes into the same system where the sewage is going. And when it goes into the sewage system, it kinds of adds to the treatment process. They help the treatment process and it accelerates even further. One of the examples, the case studies that I would like to share here is that about the floor cleaner. Now, this floor cleaner, after wiping the floor, after mopping the floor, you can actually, dump it in the garden. You can actually dump it in the flowers or in the pots that you have in the house, and it actually acts as a fertilizer. So that's the kind of power of enzymic cleaners. We also have, fresheners or I would say odor controlling system. These are also enzyme-based system, and this acts on root cause. So they don't kind of give you a asthmatic problem or suffocation or allergic reactions. These are completely water-based natural solutions. As I also said that we do have a food waste composting system. So this is not a machine that we have. It's a completely manual system. It takes up to 1 month to degrade and convert the food waste into compost. But again, the idea here is to use bacterial culture, specifically curated bacteria, to kind of degrade that. And it's an aeration process, so no leachate, no flies, nothing. And completely scalable. So if today, I mean, from a household of 1 or 2% to a campus of say 1.5 ton, 2 tons per day, it's possible. So we have been doing these things, these products or systems have been implemented at Navy, Indian Navy and Indian Air Force in their campuses to treat, 1.5 tons or 2 tons of waste per day. So, and even if it grows further beyond 2 tons, it's pretty much scalable. And this is one of the important technologies that I wanted to actually talk about, because we are talking about Jeevan Mission and talking about the rural areas. So these are again bacterial cultures clubbed with certain technologies which can be incorporated to treat the toilet waste, develop packaged, decentralized as well as centralized STPs and septic tanks to treat the toilet waste in a very different manner. So the beauty of this product is that it kind of degrades the sludge into manure. So the output is nutrient rich water, which can be actually used for irrigation, which can be used for gardening. And like this is a live site at the shore of Rameshwaram, just across the beach. And because it's on the beach, on the shore of the beach, there are certain restrictions of building and creating the infrastructure. And there was no sewage network, no water supply. So we created underground septic tanks. We are dosing these bacterial cultures, and the blue colored box that you see, there is a filtration system implemented here. We could have done this without even the filtration system in place. In absence of the filtration system, you can definitely use the output water as for gardening or for irrigation. But the cafe actually wanted to use it for their flushing and for different other cleaning purposes. So we are actually treating the water which is coming out as a toilet sludge, and we are putting it back into the system so that 50 to 70% of water requirement goes down. So this is a cafe in the front, and at the back you have public toilets. So cafe and toilets are being clubbed, and this whole circular system has been created over here. This is
Mr.
the backside.
Banerjee, sorry to interrupt. If you can finish your presentation next
Yes,
3
sir.
minutes. Sure.
Last slide, sir. So this is a schematic of how the system works. It can be also implemented for isolated kiosks, standalone kiosks for places where you don't have sewage networks, you don't have water supply, both urinals and toilets, it can be created. And if you look at the right side image where water is coming out from the pipe, this is the kind of output that you get without the filtration treatment. Just the raw water which comes out after the bacterial treatment of the sludge. It's purely safe, it's completely safe. You can touch it with your bare hands, no infection, no odor, no foul smell, and directly can be used for irrigation. So yeah, an overview of what we have, and fortunate to share that, we have been kind of received a lot of accreditations and awards in the past for our work. Thank you so much again for giving me this opportunity to share the work that we do. Happy to take up any questions or queries that you have.
Yeah, thanks a lot, Mr. Banerjee. I think you talked about these products. We'll surely take one or two questions later, but now we'll move to next presentation, and it will be by my colleague, Dr. Baban Bansod, and Mr. Singh also talked about the type of work he's doing with the team of CSIR. So Dr. Baban is Senior Principal Scientist with the CSIR Central Scientific and Instrumentation Organization, Chandigarh. He's very passionate about research. He has about 16 years of experience in research, and some of his contribution about science and technology include he's generated 4 number of technology. He has transferred also few technologies successfully to national level industries. He has filed 1 patent. He has also made publication. And one good part which he has mentioned in his CV is that he has transferred technology. What happens normally in the laboratory or research institute, people try to confine to the laboratory, but Dr. Papan is one of the scientists, rare scientists who actually believe in translating lab-based technologies to the field. So over to you, Dr. Baban, for your presentation. Thanks.
Am I audible to all?
Yes, yes.
Yes, good
Your
afternoon.
slides also visible.
Yes.
Yeah, so nice of you. Just slight correction. Pawan sir said 16 years of experience, but I am almost completed 21 years with the CSR family. 22nd is now ongoing about my experience in CSR and research. Thank you once
But
again.
you look so young. I thought that you completed only 16 years.
Thank you so much for all that, and with the guidance of my seniors like Pawan sir and all that, and especially JJM ministry, we are now on a journey to implement something very wonderful thing in across the country about this affordable IoT enabled low cost water delivery monitoring sensing system for rural deployment, and we call it as a kind of a vision of CSR and Jal Jeevan mission to kind of act like a custodian and torchbearer for the complete IoT enabled water service delivery monitoring, and completing the complete expectations on that in that regard, so that water losses and all that are taken care, the quality is taken care, and the LPCD amount of LPCD to be delivered is taken care, and what is happening across the country on ground should be known just with the click of button. So so I will go forward with my slides and try to do justice to what we want to cover today as regards the latest emerging technologies in the water. I'm just trying to make the slides move. Okay, so this is the slides which will talk about what I'm going to cover. That it consists of basically the rationale behind why we are doing this, then motivation, and what is CSI state of the art going to help in the JJM. About the incubation, I'm not going to cover. I'll be just going to touch upon what we are actually technologically trying to do with the Jal Jeevan mission, and we'll be trying to create some cover some of the glimpses about JJM and implementation through CSIR. So the basically, firstly, I'll try to talk about just little bit. We are all aware, and I'll try to be very, very brief about it. But there is a rationale behind why we should be doing all this. There are a lot of issues as regards the poor water quality is concerned in our country. Although we are blessed with a lot of water resources, but most of the water resources are contaminated. And India is already projected on the in the world map that which is going to suffer from water scarcity. We are not going to act in time, and there are a lot of parameters, city specific parameters, which are suffering from a kind of water contaminations, and they are falling low on those aspects, quality index. And we can see here that India has been ranked a kind of 120th in 122 out of 122 as far as the water quality and contamination is concerned. So which is a matter of concern for all of us. And on the other hand, the per capita water availability, which is supposed to be 1700 cubic meter, is already dropping down to 1000, and will be almost near to the water scarcity and stress level. So this is informed. And as regards the specific problems with the urban and rural is concerned in the present scenario, we as India ranks 133rd in the world ranking with respect to the amount of water available per person, and second as far as the water consumption is concerned. And we have, this is the cubic meter capita water availability in India. And there are several issues like quality issues, water thefts and leaky pipes, faulty meter readings, non-availability of real-time data, manual assessment using lab analysis methods, calibration and maintenance, cost-intensive infrastructure, trained manpower is something that we have to look into, time-consuming test protocols, manual fault finding. So this is what is basically the genesis for Jal Jeevan Mission. And rightly, timely, Ministry of Jal Shakti identified these issues, and they are very, very serious and aggressive about addressing all of this. And that is where now CSR is already on board with them, and we are trying to help them, and we have joined hands and will address these issues. As a result of these present issues, why we need to look into it and provide a solution? The reason is that because of all these aspects, we are unable to give the timely and quality of mitigation in terms of water quality and quantity management, which is suffering. And another issue is that consuming polluted water in any ways has a lot of disastrous effect. Most of the diseases are waterborne diseases, and loss of water in both ways, qualitatively as well as quantitatively, is happening. And we have no check to see to it that what is actually happening, because there is no digital data available right now. And overall scarcity of quality water in many parts of the country because of this. Now, on one hand, we have a lot of issues that we have seen, and there are facts and figures to it. But on the other hand, we have a lot of water resources available in abundance. And if these are taken care of, I think surely we'll come out of these issues. So we have a lot of rivers in this country, a lot of lakes and water treatment plants and bore wells. And if we can, monitor these with the good monitoring technologies, and that will help us to take the remedial actions in time. Then another genesis as far as the Jal Jeevan Mission, this low-cost IoT-enabled water monitoring technology is concerned. What is the genesis? That presently, all these technologies that are available to monitor the water quality, they are basically lab-based, and as a result, they are very time-consuming. They are capital-intensive. They need the trained manpower, and as such, it is not serving the purpose to the required extent unless and until we have something which works in the field. Uh, and then on the other hand, as Singh sir rightly said, that if we have to think of upscaling across the pan-India basis, we need to have indigenously available solutions so that repair, replacement, and the cost effectiveness is also addressed. So all of these presently available state-of-the-art technologies from the abroad, they either have cost issues or they have some kind of shortcomings also in the context of Indian customization or our specific geographical location specific solution providing. So they have to be customized, they have to be they have to be tuned to the specific requirement, and moreover they have to be affordable. Otherwise we cannot upscale the pilots, we cannot think of employing them, deploying in them for the water quality monitoring, because just to quote you an example, a single arsenic sensor will cost 2 3 or around 5 lakhs rupees as far as the online monitoring is concerned. So these are the various issues, and then if something goes wrong, there is no repair replacement available, and the breakdown time for that matter is very, very high, because being imported sensor, they take 2 3 months to arrive at the India. And moreover, we should be developing our own indigenous ecosystem so that we can take care of all these aspects. So that is something called as a genesis and motivation that we want to take care of. And this is the kind of specific problem statement that JJM wanted us to address about. This talks about the developing the cost-effective quality sensors, various like TDS, pH, arsenic, iron, nitrate, fluoride, and for quality, for quantity measurement also, ground for ground level ground source sustainability also, we have to develop the ground level sensors and flow meters. We have to customize and get it integrated with the IoT environment, and we have to also develop a complete calibration and kind of standardization protocol, so that there is the interoperability between the different platforms, and we should be comfortably able to upscale it across the country. So these are some of the issues that we are supposed to address, and various labs have been, we have formed a consortium of CSIR and joining hands with JJM team to address this. Now, why CSIR team will be able to do this? Because there is a lot of success story behind it. We have already developed some of the leads that are available in the labs, and now we are transforming them into the field scale technologies to customizing with the JJM requirements. So all these knowledge base in terms of these technologies are being now used in the Jal Jeevan Mission, and to see that it sees the light of the day in the field, especially to address the technical compliance and the requirement by the JJM in terms of various sensors and software. So we have all these technologies which are now going from the lab to the field and taking care of the requirement of the Jal Jeevan mission. We have our own indigenous dashboards, we have our own indigenous cloud, we have our own indigenous solar-based solar tree, which will be powering up all these network of IoT architecture. We have our own these optical level switches, and we have customized our own TDS, pH, and all these sensors also, which will be deployed in the fields. So with that strength and with lot of knowledge base and science, research and development science that we are possessing from within the CSR lab, now it will see the translational activity from the lab to the land. And these, as a result, we'll be able to address the various stakeholder issues like on-the-go measurement of water quality, quantity, and regularity. And because of this IoT-based solution, we'll be able to give the forecasting of the demands and the current source levels, recharge patterns, and usage patterns, which will actually help the officials on ground and also in the various levels to take care of the operation and maintenance costs, and also to help them timely interventions in terms of the remedial actions. Because that will provide a complete on-the-go measurement of the various parameters like water level, water quality, pump on, and ground source sustainability levels also. Now, the solution, what we are doing is we are providing the various sensors that are deployed at various, across the distribution network in the different DMS, habitations, clusters, and starting from the source to the end level user level, that what is the at the source, what is the ground level, what is the level of the source, what is the chlorination level, what is the total aggregate amount of water that is being delivered across the delivery network, and at the distribution level also, and the various DMS flow meters are going to be there. So we'll know all the parameters such as what is the leakage, what is the pressure, what is the chlorine, all these. So as a solution, this is what we have designed at CSIR, and we have these different, as far as the technical details are concerned, we have these sensor networks and cloud and application. There are basically 4 key research vectors which are going to solve the complete problem statement, wherein we'll have our own sensors, customized sensors, as well as indigenous sensors, in-house and off-the-shelf sensors. They'll be sending the data to the specific appropriate IoT technology using radio frequency or GSM based protocols, and that will upload the data to the cloud, and then application consume layer will use it at anytime, anywhere, any device, like on the mobiles or desktops or tablet. This will be transmitted. So across the 4 work packages and 4 key technology components, various labs are putting their efforts together. They have joined hands, and this is the architecture that we have proposed to the Jal Jeevan mission, wherein the physical environments like service reservoir, distribution lines, and the end user functional household tap, we are actually completely digitizing the whole thing, and completely whole water resources are digitized in terms of deploying our device layer to them. For example, for source side, we are deploying the water source level sensing, then flow meters are deployed across the distribution network, and water quality sensors are deployed for to take care of the water quality that is reaching at the functional household in each households. So after that device level, now we are also taking care of the various protocols that should be taken care of, universalization and the standardization of these protocols as per the JJM requirement, that they will be sending all the information in the JSON format, and then this information will go to the communication layer through, let's say, LoRa, long range and low power and long range communication for first mile connectivity, and for different design requirements like basic, intermediate, or advanced, and then this through appropriate, let's say, BharatNet or some other connectivity, will be able to transmit it to the cloud. And finally, in the consume layer, we will be able to get different alerts and reports to the appropriate stakeholders for the remedial actions. And we have to actually do this in a proper manner, and we have to follow all protocols. For example, for communication protocols, we'll be using MQTT or HTTP protocols, and for network security, we'll be using the TLS, DTLS layers, so that the network is not hacked and there is no tampering. So all these things are taken care, and this will be all complying with the various recommendations of the IEEE standardizations that is required, and then various format that are required to be taken care. So all this is designed across depending upon the requirement of the compliance, and this will be followed in the JGM project. And as I said, we are going to provide the solution in terms of basic, intermediate, and advanced design, which will provide us different key performance indicators. For example, we'll have total aggregate water that is being delivered from the source side, and what is the chlorination level in case of basic for starting from the source. So on. As we go on adding the different nodes and sensors, we'll be able to have different key performance indicators as required by the particular. That will depend upon the complexity of the village and the requirement of the village. And we have proposed a specific solution so that all cost optimizations and the complexity of the village is taken care of, capacity of the village is taken care of. We have here star of star topology, which will be deployed across different villages, wherein each cluster will be able to send the data through these gateways and aggregators, RTUs, to the master gateways. And there are different layer of the sensor nodes that are distributed across the pilot locations, which includes the flow meters, which include the pressure sensors, and they are typically will be transmitting the information in terms of JSON formats, which is the requirement, so that there is a complete interoperability, and there is upscaling possibility. So for example, this gateway ID for a pressure sensor, reservoir water level sensor, it will sense the service reservoir level and battery level and errors. All these will be available in the dashboards at the state level, as well as at the cloud level, as well as the center level, and also at the local level, GPs and VPs. This information will be available. Moreover, as per the JGM technical committee report, we are supposed to comply with the requirement that each RT will be capable of storing the information for 30 days, and each this master gateway will be able to store the information for 60 days. So, and this all will be able to communicate bidirectionally, so that calibration things are fixed up, or over the air this pattern this over the air the algorithms are designed such a way that we'll be able to take care of the tampering or any other abnormalities, anomalies in the sensor network or at the particular cluster, whether sensors are working, whether the calibration is perfectly working. So all those will be taken care, and also to fix the some security patches also, it will be able to send the commands from the cloud. So this is how the whole network has been designed, which will help to ensure that the requirements are completed. And as I said, the information will be pushed from the state to the cloud, will be pushed from these all master gateway aggregators to the state clouds, and from state clouds it will go to the center clouds, and each at different stakeholder levels, starting from the pump man to the village, blocks, district and state and center. There are different privileges provided, so that they are able to download specific reports, or they are able to take a specific action, for example, switching on the pump and off the pump, or any other aspects, remedial actions. Just with the click of button they will be able to do it. So okay, this is a just a specific clip that I would like to share. It will just show how the whole system will work.
Yeah, Dr. Bhuvan, I know that you will be completing it soon, but if you can wind it up in next 3 minutes.
Sure, sir. Yeah, so this is what the vision is, that how whole water resources will be digitized by CSI team along with the JGM guidance and their support, and all the sensors will be mounted to transform the water resources into digital form. This is the complete timeline that we would like to establish and deliver. We are already at month 6 or 7 here. We are expected to start the upscaling and demonstration of the pilots, which is what we are doing, and in the process of, and we are also taking up the industries to help us as far as the upscaling is concerned. Once we demonstrate some of the pilots, the industry is also on board to take care of the complete upscaling across the country for various states. This is the complete team that is participating in the program, so that everything is moved very systematically and timely. And these are some of the innovations that CSI team intends to deliver, which includes the indigenous IoT architecture comprising of 4 technology components, data integration layers, so that there is interoperability, and across the country we will be having the upscaling possibility, and any sensor from any company will be able to replace, just plug and play once we have this ETL layer inside, embedded inside all the sensors, and for standardization of the protocols, calibrations, and we have indigenous softwares like risk finite and vulnerability, and we have a lot of data analytics using all AI and machine learning algorithms to predict various analytics. And as a result of all R&D, we are able to address the issues and will be able to deliver on all these. There is a consortium of CSI which is taking care of each particular. They are complementing the strength of each other, and we intend to deliver a final outcome to the JGM team that will be able to, because of this digitization, we'll be able to have assured water quality and increase the availability of water, because leakages and all that will be plugged in, and we'll be able to ensure that 55 LPCG to the rural areas or 155 LPCG to the urban areas, and reliability and sustainability of water resources. And necessarily important aspect is instilling the necessary behavioral behavior change in rural water supply department, because once everything is available in digital form, it will also help to instill the necessary behavior change, and tamper detection mechanism will be also inside it. We are using a lot of advanced algorithms inside, all at the sensor level, gateway level, and the cloud level. And this is very important aspect, stakeholders connect, wherein we are presently step 1 lab scale trials we have completed, step 2 field scale trials we have deployed in one of our field testing test bed control conditions, like science center we have deployed, one we have created at CSIO. This we are in these are getting tested and so on. And finally, third, we wanted to do this all demonstration deployment across the states with the help of the industries, for whom we have already prepared a SOP for all the industries, so that they get empaneled and most preferred partners, those who are having the relevant experiences and have a capability to work with the CSI team under the knowledge base of the CSI, guidance of the CSI. They'll be able to upscale it across the country using our knowledge base. So this is what this stakeholders connect is there. The vision is basically like this, that Ministry of Jal Shakti is here. CSI is already working on all developing all knowledge base, software, hardware, and will upscale across the country with the industrial partner for the implementation of 115 clusters, which will comprise of thousands of locations. And what are the benefits to the states if we do like since we are going through the JJM and CSR partnership, is that technical and commercial compliance, there are no irregularities and complete technical compliance, because being into being R&D institutions, we are completely understanding all this, and we have already prior knowledge base in this regard. So
Yeah, Dr. Pavan, next 1 minute, please.
Yeah. And uniformation and standardization, which is very, very important aspect of this program, that for as far as the upskilling is concerned. So all these benefits will come handy for the JJM and states, and indigenized products as a result, repair, replacement, and downtime will be very less. And we are in turn also will be creating the complete startups and ecosystem within the country to take care of all IoT enabled system functioning in the country, whether it is for water or for wastewater. All that ecosystem we have to create, because we cannot rely upon imported things. That will be very costly, that will be breakdown time will be high. There are so many issues with that, and unless we build our own indigenous ecosystem to take care of all these, just by importing solutions and solving our problems will not help. But that is where I think Ministry of Jal Shakti has taken very, very taking right step, putting at the right time, that bringing CSR on the platform on board, and then we are taking care of these all things. And then long-term hand-holding and support, being as a government body, we also are looking into providing a long-term support, being a government body, as far as the operation and maintenance aspects are concerned, and local ecosystem that I have already mentioned. And third-party validation, being into already R&D institution, will be a kind of complete compliance, and will be building those kind of systems and all the documentation which will ensure to do that. So so what we see is that the CSIR, JJM together as a torch bearer and guardian for the implementation of CSIR, JJM's IoT-enabled water service delivery monitoring pilots, and custodian of knowledge base, so that this all knowledge base is available to the industries, and we will be guiding them to implement all these, and torch bearer for all the IPR, or you can say standardization, or the documentation which should be referred as a kind of benchmarking, that okay, it has to be like this, and across the country uniformation and standardization will be ensured by the CSI team with the partnership with the JJM. So that's what all from my side, and thanks for your patient listening. And I hand over to Dr. Pawan, and thanks to him for giving me the required time and to deliver these contents on IoT-enabled water service delivery monitoring, indigenous water service delivery monitoring system. Thank you.
Yeah, thanks, Dr. Baban. It was very, very interesting presentation. And I see now, once this system is implemented, the entire landscape of rural water supply system will change, right from operation, maintenance to monitoring. And we really look forward to implementation of this particular project with the help of and support from JJM. I'm sure it will be done soon. And one word in your CV I liked is passionate. You are really passionate about your work. That really indicates the way you have made presentation. So thanks a lot. So we'll now move to the last presentation of this session, which will be by Mr. Avinash Patru. And Mr. Avinash is Assistant General Manager, Marketing and Communication. Avinash is an engineering graduate from Biju Patnaik University, and also there is masters from SIBM Pune. And Mr. Avinash is working in Xylem, India, and has more than 15 years of experience. And he also mentioned that he is passionate about environment. So over to Mr. Avinash, who is another passionate person to environment. I'm sure that he'll make equally interesting presentation to us. Over to you.
Thank you, Dr. Bhavan. You all can hear me, right? Yes, and you can see my screen, right?
Yes.
You can see my single screen.
Your presentation also, yeah.
Yeah, it's a single screen, or is it a dual screen you are seeing currently?
A single. Yeah.
Perfect. Okay, so good afternoon, everyone. I will not take much of your lunch time, so let me try to complete it within a stipulated time. So thank you again for this opportunity giving to Xylem to discuss on some of our emerging technologies. So we'll focus on more on new technology and data analytics. And this will be a high-level presentation, ladies and gentlemen. So anything you need in detail, I would love to connect with you and discuss with you. As Dr. Boban mentioned, like complementing the strength of, so we all have some strength. So how we all can work together to solve these water challenges. So Xylem, if you all know, we are a pure play water technology company. Okay, so core strength we have is the complete water cycle ecosystem. Okay, starting from transport of water. So we manufacture pump, be it large pump used for like drawing water from sources, be it booster pump, be it wastewater pump, so industrial pump. So we manufacture pump. First is to transport water. That is the prime business we have. Second is, once we transport water to where it is, very important to treat the water. So we as a company, we treat both the water treatment and also the wastewater treatment. In treatment, what we do, technologies like filtration, disinfection, biological technologies like SBR, real-time water quality analyzers are some of this we achieve the treatment part of the technology. And today I'm here to discuss about all this transportation treatment, how we track and transform because it is very much important to optimize the complete water and wastewater network. Okay, so Mr. Babban mentioned about IoT, about AI technologies, how we can completely optimize the whole network, starting from pumping of water till the last step of metering, collecting the information in this digital information. So this is all about I'm going to speak today, ladies and gentlemen. Yes, how we do this track and transform. But before that, we have to know what our customers need, what actually they need from this digital transformation. They want compliance. They want to adhere to the compliance, be it discharge regulation compliant, be it treatment compliance. This is what the first is. Second is cost saving, be it saving their operation cost, that the recurring cost, how we can save the cost saving. Third is a risk reduction. Can we proactively identify where the risk is and take action, and sustainability. So these are the things which our customers need, and what as a company, what we provide. One is sensor technology, the complete sensor technology portfolio, smart metering, be it water metering, gas metering, or this metering technology which we provide, communication technologies, measurement and data analytics. So these are some of the digital portfolio which we provide. Objective is, as Dr. Singh mentioned, how we can reduce the NRW loss. He mentioned about 40 to 45%. How we can reduce is not a single drop of water to be wasted, so that we get maximum efficiency from the whole network. How we can improve the performance, how we can lower the cost, and providing great customer service. So our motto is let's solve water by providing great customer service. So all this portfolio, all these products we have told, be it pump, be it disinfection, filtration, treatment technology, we all have combined everything. And this is something called digital technology. We are telling is Xylem View. Okay. For smart and connected device to intelligent system services, the Xylem's View is basically a full suite of technology covering all the solutions which we have. Okay. Now, this is a framework which we operate. Each and framework we can detail in detail. So whoever wants to connect with us, be it wastewater network optimization, very, very important. The complete network, how we can optimize and how we can reduce your overflows. You can see by 450 million gallons of annually of water. This is, we have reduced the overflow by simply wastewater network optimization, be it through AI and ML devices. This is very important. And the capacity utilization optimization that has resulted in reduction of overflow. This is one of our core thing. Second is, as a water treatment company, technology company, the treatment system optimization, the complete water and wastewater treatment optimization, this we do so that we can reduce the energy consumption. You can see 30% reduction in energy consumption is huge, and the efficiency it can bring to the system is really remarkable. Third is the water loss management. This is Mr. Singh was mentioning about how we can reduce the NRW, how we can reduce the leak. I will show you a very interesting video, which I just love that product and how the product works. Okay, this is more about leak detection, more about technology to reduce the leak. Fourth is a revenue locator. This is because each and every penny lost in terms how we can use smart metering, how we can save and how we can enhance the revenue for our customers. This is where we work. And the asset performance management, be it the pipeline maintenance, be it predicting what kind of failures we can get, okay, and getting better accuracy. So this is what all the technologies. So again, each technology, it is a subject in detail. So my request to the humble esteemed colleagues here is, whoever wants to know, please connect with us so that we can discuss all this technology in detail, how we are solving this customer water challenges in terms of digital technology and water treatment. What is the potential now? So this is a report which GWI, Global Water Intelligence, published. Globally, $70 billion of dollar. It's a potential annual saving from digital. This is where we as a company are. This is our goal. How we can be a part of this journey and save this much money for our customers, resulting in 3x faster growth. You can see all other technologies are growing at 3%, but as Mr. Goban also mentioned, digital is growing at a very faster rate, 9% globally, and this is what we as a country, we as an India wanted to be in this and leverage this technology. savings are enormous, ladies and gentlemen. You can see wastewater pumping, we have reduced the energy cost, energy reduced by 50% annually. Aeration, the power cost can be reduced by 26%, and overflow can be reduced by 271 million gallon, and water efficiency, the workforce efficiency, because now you don't have to worry about your water plant, water network. Everything is there in the digital system, and we can see. I would like to show one video which I really love, and this is my last video. This is a 2 minutes video, and I will complete my presentation. So here comes the video. This is we call it a smart ball. Okay, so this already we have implemented for some of our customers in India, and they really love this ball because what it does. Have a look. Can you all hear the audio? It's an acoustic sensor already there in the smartphone. It can detect the leak. GPS, it is ultrasonic transport transmitter, it is train gauge, it is temperature transmitter, all this in one ball. Yes, this is just a glimpse of one product which we have. Sorry. Yeah, this is just a glimpse of one product we have, but similarly, we have all our products, be it pumps, be it disinfection, smart metering, level transmitter, full transmitter, everything is connected to the digital service. And yes, as we all agree, digital, when we say we have an opportunity of a lifetime to be a part of this digital journey and to work with all of you. And end of the day, let's solve water together. Thank you very much. This is my email ID, my phone number, everything is there. If you want to connect with us for any specific technology, we would love to discuss. Thank you very much.
Yeah, thanks a lot. Very, very interesting presentation. And I would like to thank all the presenters, speakers today, because not only they talked science and technology, but they could complete the presentation, a speech within given time. So fortunately, I had to now summarize the well. Is that what I need to do?
Yes, sir. So if you can announce the 2 3 highlights that came out of the session.
Yeah, I will not take much of time, but let me just briefly talk about what speakers told, because we still have some time. So first of all, Mr. Singh, he briefed about Jal Jeevan Mission Rural. And one of the highlight of his talk was that once the water supply scheme is completed, that is handed over to Gram Panchayat for operation and maintenance. And you can imagine Gram Panchayat in rural Jharkhand, or for that matter, rural Madhya Pradesh, what sort of technical capability these Gram Panchayat will have, so that the technology should be made in such a manner that the technical resources available in GP can properly operate and maintain. And he later talked about the technology selection dilemma. He, in fact, was speaking about a treatment technology for geogenic contaminants such as arsenic and fluoride. And he briefly talked about this committee under principal scientific advisor and the portal available on Jal Jeevan Mission, and anybody, the technology developers can in fact feed the details about this particular technology. And later he briefed about this a need for IoT enabled water supply system, which later Dr. Baban elaborated. And he mentioned that our goal is to supply 55 liter per person per day of water. And on my question about this IoT enabled system, he told that more than 100 projects are being implemented and they're being monitored also. So yeah, thanks, yeah, Mr. Singh. And later, Mr. Banerjee, he talked about his company, which was, I think, incubated in IIT Delhi. There were like 3 different themes: to reduce consumption of water, not to pollute water, second theme, and then treat wastewater, household or industry wastewater where it gets generated. And he brought that concept of circular economy around this particular subject. And he presented about 6 verticals, and one which is bread and butter for his company's waterless urinals, and we can see more number of waterless urinals, not only in airport, but even we can see in some of the modest buildings also nowadays. And he talked about natural cleaners because the artificial cleaners have some contaminants which can further deteriorate water quality. Even natural fresheners also was discussed. And one of the interesting technology discussed was food waste composting. And then he also talked about waste management, the clean toilet, and then he has shown a case study of Rameshwaram where actually is treating this fecal sludge, and then I think the separating urine, and then the urine, the wastewater can be treated to such a quality that it can be handled with bare hand. So that's very interesting presentation. The third was by Dr. Baban, and he talked about affordable IT-enabled low-cost water delivery, and the CSI consortium is working on he started his presentation by highlighting concerns of water supply system, particularly in rural area. How can the water quality monitoring, which is being currently done by using lab-based water testing, the sensor-based system can complement this water quality monitoring. He also talked about expensive imported water quality sensor. He dwelt upon CSR work which is going to be there as part of this particular project on monitoring water quality, groundwater level, flow meters. And in addition to using off-the-shelf sensors, sensors will also be developed by CSR consortium, which will really help us to have our own indigenous system. So here's presentation of a high-level solution diagram, which included sensors, networking, cloud, and applications, and advanced design of how this project will be actually utilized. The last presentation was from Ms. Patro, and he talked about his company's Xylem, new technologies and data analytics. And as I mentioned in the beginning, that we really cover the entire water cycle, and he actually talked about transportation of water, bulk transport, and then pump, which they are having, water treatment, and he also talked about sensor technology, smart metering they're working on, they have with them, a communication system, data analytics at all. And one of the quote I'll refer from his presentation is we have like a market of 70 billion or saving which we can have by going digital. That's really incredible. So if we can digitize our water supply system, I'm sure that part of the cost will be recovered. So at the end, he has shown this digital bar video, which was very, very interesting. Let us see that how best it can work in our system. So it was, I think, great presentation by all the speakers, and I would like to personally thank them. It was a good blend of speakers from government, research institute, and industry. So with this, from my side, I'll conclude. We don't have time for say questions, so now I'll hand it over to Dev. I think we can finish off this session within given time. So thanks to the speakers. Over to you, Dev.
Thank you, Dr. Pavan. Indeed, it was a very illuminating session and a lot of good thoughts were exchanged. I would once again thank you everyone and requesting all the participants to join back at 2:30 for our next session under the same theme, focusing on innovation, technology interventions and smart water ecosystem. See you all shortly. Thank you.
Thanks a lot.
Thank you, everyone.
Thank you.
Thank you, everyone. Thank you.
Thanks.
Thank you. Thank you so much.
Thanks.